Hello, my friends, and welcome to tutormymath.com. I am Darren, and it is Tuesday, which means it is time for Numbers for Algebra. Numbers for Algebra is a course intended for adults who are planning to take a college algebra course, but maybe it's been a few years or maybe even a few decades since the last time you took a math class, or maybe the last time you took a math class, it wasn't a pleasant experience for you. So Numbers for Algebra is meant to build your numerical literacy skills as well as instilling confidence that you can be successful in math. And today I'm going to take you through a very quick, very straightforward warm-up. We have been talking about some of the key ideas. We're just getting into the course, and we're going to briefly talk about our multiplication facts today in this week's session for Numbers for Algebra. And we're going to use this little warm-up here as a way to get the conversation started. So on the screen here, you can see we have the numbers 2 through 13 in a variety of colors, fonts, sizes, a few different fun things going on here. Go ahead and just pick whichever number below you feel the most drawn to. There's no right or wrong answer here. Go ahead and just pick whichever one calls to you the most or whichever one you like the most. And what we're going to do is I'm going to put a few questions up here on the screen. But before we do, let's go ahead, take a second to clear our minds by breathing in slowly through the nose into your belly. Let it go. And let's begin. So the number that I picked was, go ahead and write that at the top of your page there. What number did you pick? And then write down the first three words, thoughts, phrases, or anything else that comes to mind as you think about your number. What comes to mind as you think about the number that you picked? This can be anything, does not even have to be math related, just whatever thoughts come to mind. Write down at least three. If you can think of more than three, you can write down more than three. And again, because this is virtual, no one else can see what you're writing. So maybe some difficult memory comes up. Go ahead and just write down whatever comes to mind as you think about this number. Now, is your number even or is your number odd? Is it even or is it odd? And hopefully we know even and odd. If not, that's okay too. Is it even or odd? Next question is your number prime or composite? Prime and composite, two very important ideas, particularly primes that we've been talking about the last few weeks. Prime numbers are sort of at the core of everything we talk about in Numbers for Algebra, because we are really talking about the most important thing that you need to know about numbers, and it has to do with what it means for a number to be prime and why prime numbers are important. So is your number prime or composite? Next question is your number easy to multiply by? Is this number easy to multiply, or is it a little bit more difficult? Some numbers are harder than others. Some numbers are a little bit easier. Write your thoughts. Is your number easy to multiply? And finally, what is 7 times your number? What is 7 times the number that you picked? Write your answer there. Take a second. Go ahead and finish that. All right, let's go ahead and do one together. So the number that I picked was the number 7. And the first thing that comes to mind is that 7 is my favorite number. That's part of the reason why I picked it. Maybe it is your favorite number too. It's my favorite number, not only because I was born on the 7th, but because in the little research project that I'm working on, it ends up being a very important example of the properties that we're trying to study. And so 7 is sort of the one that breaks the easy patterns, and the more complicated patterns start to emerge, the more general case. So it's a number that I think about quite a lot. Another thing that comes to mind is thinking about the number 7 is 7 colors in a rainbow. 7 colors in rainbow. Roy G. Biv, if you remember that from elementary school, right? And again, doesn't necessarily have to be a math fact. It can be any sort of fact. We could also say 7 days in a week, something like that. But the third fact that came to me that I wanted to put down here is a 7-sided shape is called a heptagon, also sometimes called a septagon. Hepta, I believe, is Latin. I think septa is Greek. I could be wrong. Someone fact check me on that. So we have two different words for heptagon or septagon. Both mean 7. Hepta means 7. Septa means 7. So like September comes from 7, but for some reason is the 9th month. If you know why, let me know. And so that is 3 facts about 7. Again, anything that comes to mind is an appropriate answer here. We like to practice little exercises like this. Sometimes we do very long form divergent thinking exercises. Sometimes we do little short ones like this. But the idea is just to see what comes to top of mind. What do you think about as you think about some of these numbers? Now, 7 obviously is going to be an odd number. Odd meaning that it cannot be divided by 2 evenly. 7 divided by 2 would be 3.5 or 3.5. Is your number prime or composite? Again, prime and composite, this is sort of a review from some of the concepts that we've been talking about the last few weeks. We're going to see that prime numbers are very important. The most important thing that we need to know about numbers has to do with the prime numbers, and that's the concept that we are really diving in towards, that fundamental theorem of arithmetic and understanding why prime numbers are important when we start to study algebra. And so 7 is prime. Is your number easy to multiply by? I'm going to go ahead and say no, not really, right? It's not as easy as say 2 or 10 or 5. There is a trick that you can use for multiplying by 7. If you notice that 7 is 5 plus 2, 5 and 2 are a little bit easier to multiply by. So if you have a number, you can multiply it by 5, you can multiply it by 2, and then add those two numbers together, and that will give you what it is if you were to multiply by 7. We call this the distributive property. Which if you've studied algebra or prepared for algebra before, you might recognize that's one of those important terms. And in numbers for algebra, we use the distributive property to do division a lot more than we use long division. We know long division in this course. And finally, what is 7 times your number? Well, 7 times 7 is 49. And this is when I was in, I think, 4th or 5th grade, when we were first memorizing our multiplication facts, our teacher would have us do these mad minutes where it'd be like 60 problems, like arrange 12 problems per row, 5 rows, and you have a minute to do as many as you possibly could. And I think there was some sort of reward or something for every line that you got right. I think you got, I don't know if it was extra credit or something else. And I remember that morning I had practiced my multiplication facts. My mom and I were sitting in the kitchen working on some of these things. I went into class feeling so confident I was going to get a ton of problems. I was going to get a ton of rows completed. I got to the end of the first row, and 7 times 7 was on there, and I could just not remember it because I didn't have any other tools to figure out what 7 times 7 was. I was solely relying on memorization. I remember just feeling so discouraged that I couldn't remember 7 times 7. So I vowed to never forget it ever again. I committed that one to memory. And actually knowing your perfect squares, right, a number times itself, so 7 times 7, those make for good launching off points, the other tricks that you can use for multiplication facts. And so 7 times 7 is 49. So pretty straightforward here, right? There's nothing too crazy going on. We do these warm-ups just to get our math brains going, and there's usually a reason why we do the warm-ups that we do. And in this week's session of All About Numbers, we're going to briefly talk about multiplication facts and a few of the little tricks that we can see here and there for multiplying certain numbers. But we're actually more interested in getting into the divisibility tricks, right? The how we can tell if a number can be divided by another number. So whatever number you picked, we had a few different options here. As we look at this list of numbers, which of these numbers are easy to multiply? And again, some of them are easier than others. For example, something like 2, usually very easy to multiply by, right? If I even give like a 7-digit number, a 4-digit number, 1733, and I want to know what is that times 2, we just double it, right? So we know that that will be 3,466 because we're just adding the number to itself. There's a neat little trick for multiplying by 5. Again, if I have something like 72 and I want to know what is that times 5, simply multiply 72 by 10, which is easy because we just add a 0, and then cut it in half. Half of 720 would be 360. So 5 times 72 equals 360. We already talked about 10, right? 10, very easy to multiply by. You always just stick a 0 on the end. Why is it that 10 is so easy to multiply? Why is it that 10 is wearing a crown? Well, because 10 is our base number. We base all of our number system off of that number 10, mainly because we have 10 fingers. But as we've talked about in other courses, the number, there's nothing special about the number 2 times 5 being our base. Our ancient ancestors, the Babylonians, use a base 60. Computer binary is base 2. There are other bases that come up in various applications, but for when we talk about the way that we traditionally use numbers, 10 is our base, which makes it very easy to multiply by. Even numbers like 4 or numbers like 8, what's the trick for multiplying a number by 8? We at first might think 8's a little bit of a bigger number, maybe it's a little bit harder to multiply by, but the most important thing that you need to know about the number 8 is that it's the third power of 2, 2 to the third power. Otherwise, it's 2 times 2 times 2. So for example, if I wanted to know what is 7 times 8, one way that we could solve this problem is to just take 7 and double it 3 times, right? Because it's 2 times 2 times 2. So 7 doubles is 14. 14 doubled is 28. 28 doubled is 56. So that's one trick that you can use for 8. Same thing for 4, just double it twice. And so we might notice that so far we've covered all the numbers that are blue. Those are the ones that are maybe a little bit easier to multiply by. And we might say, well, 11 is actually not too bad to multiply, right? Because if I have a one-digit number, like 3 times 11 would be 33, 7 times 11 would be 77. That's not too bad. It gets a little trickier as we get into some bigger numbers, like if I wanted to know what is 11 times 32, but I could still do something like 32 times 10 is 320, and then add 32, right? So multiply by 10, multiply by 1, and then add them back together again. So 11 is not too hard. And then something like 9, we know that when we have a one-digit number, like so 9 times 7, there's a nice little trick that we can use here. Just take whatever the other number is. 1 less than 7 is 6. That goes in your tens place. And then what do I add to 6 to get back to 9? Well, that's 3, because we know that the sum of the digits of a multiple of 9 should always add up to 9, or a multiple of 9. And so there's this nice little trick here for 9. If you've never seen this trick before, it's very similar to the one that people do on their fingers, right? So 1, 2, 3, 4, 5, 6, 7. You put your 7th finger down. You've got 6 fingers on the left, 3 fingers on the right. Same idea, right? Because we're adding to 9. But so there's a nice little trick for multiplying by 9. 3, also not as easy as 2 and 5, but still not too bad, right? You could double the number and then add the number on again. So like 3 times 15, you could double the 15 and get 30, and then add a 15 onto there, which would be 45. 7 and 13 start to get a little bit harder, but we might notice again that the red numbers a little bit harder to multiply by than the blue numbers. And then, of course, our violet numbers, or maybe we just call them purple for now, 12 and 6. 6 is going to be 2 times 3, which is a blue number. Oops. A blue number times a red number. That's why they're purple, because it's got easy numbers and hard numbers. And same thing over here with 12. 12 is 3 times 4. And so you could potentially, if you want to multiply by 6, multiply by 3 first and then double it. Or if you want to multiply by 12, multiply by 3 first and then double it twice. Or you could multiply by 10 and then multiply by 2 and add. There's lots of different ways that you can do some of these multiplication tricks. So if any of those are unfamiliar, or if you're struggling with multiplication facts, it's okay. It's okay to say that that's where I need to start. And that's part of the reason why we cover these very early on in the course, is because it is important to know what your multiplication facts are. I'm not a huge fan of saying go out and memorize, but definitely practice, know some of these tricks. It will come up as we start to study algebra. But the key idea here, the key idea of what we're going to be discussing in this week's edition of Numbers for Algebra, is that when we're multiplying, we're sort of answering the question, given two factors, what is the multiple? And so factors, multiple, two very important vocab words that we've already covered a few weeks ago. We keep rehashing them because that word factors in particular, this one is so important for algebra. If you're planning on taking algebra, read your algebra syllabus, college algebra syllabus. It might say that you, as a prerequisite, you need to know how to factor polynomials or factor quadratics. And so we start by learning how to factor numbers, or what it means for a number to be a factor, before we attempt to do algebra, because they're analogous concepts, a factor of a number or factoring polynomial equations. So again, given two factors, so 8 times 7, we already said we could use a nice little doubling trick here. We could use the trick earlier that I said where we could do 8 times 5 and then do 8 times 2. 8 times 5 is 40. 8 times 2 is 16. So this would be 56. Actually, in my brain, I use my perfect squares as a launching off point. So my brain goes 7 times 7 is 49, plus 7 more would be 56. Again, you can double 7 3 times. 7 doubles 14, 14 doubles 28, 28 doubles is 56. That one comes up again when we study the decimal patterns for 1/7, which is one of my favorite topics. 9 times 6, we can use the little trick again that we saw earlier where we take the 6 and when we multiply by 9, so we take the number that's not 9, the other number, and say, well, what's 1 less than 6? That's 5. What do I add to 5 to get back to 9? We would say it's 4. So 5 plus 4 is 9, and so 9 times 6 is 54. 12 times 13, a little bit of a harder one here. Again, knowing our perfect squares is a very useful thing. So if you know that 12 times 12 is 144, we can add another 12 because we're saying we already have 12 12s. We need one more 12 to make 13 12s because we know that 13 times 12, 12 times 13 are the same thing. So this would be 156. Again, there's probably other ways that we could do this. We could do 13 times 10 is 130. 13 times 2 is 26. 130 plus 26 is 156. So this is multiplication facts. But in the course, the question that we really want to be able to answer is, given a multiple, given the answer, what are the factors? What factors make that number? So if I give you 42, what are two numbers that multiply together to make 42? And there's a lot of answers here, actually. The easiest answer, if you want to just take the lazy approach, which is usually the best approach in math, we could just scale 1 times 42. That works, right? Because 1 is always a factor of a number, and 42 is always, or a number is always a factor of itself. So 1 times 42 is a perfectly valid answer. We could also say, well, this is an even number, right? So we know that it's 2 times something, 2 times 21. But the point is being able to identify from a multiple what its factors are. 360, what are two numbers? What are two factors that make 360? Again, we have a 0 on the end here, so we have another easy one where we could do 36 times 10. Again, that's not too hard to see. And there are other answers. Again, we could do 120 times 3. We could do 12 times 30. And this is the skill that we really want to start working on, is how to identify, given a multiple, what are its factors. It's going to be incredibly important to us as we understand how numbers work. We want to be able to understand numbers, how the natural numbers work, so we can understand how the rational numbers work. The rational numbers, those are those fractions, right? If we can understand how fractions work, then once we generalize that to variables, we've already got a lot of what we need to know about how numbers work in order to do algebra. We can also answer questions like, how do I find the square root, greatest common factor, least common multiple, simplify rational expressions, equivalent fractions, converting fractions to decimals, reducing fractions. A lot of different concepts that we can start to understand once we understand how to take a multiple and break it down into its factors. Last question here, 90 is, what are the factors of 90? We could say it ends in a 0, so we could do 10, 9, and 10. If it ends in a 0, that also tells me 5. What would I multiply by 5 to get 90? Well, we could think, well, that's 40 plus 50. And so 40 divided by 5 is 8. 50 divided by 5 is 10. So this would be 18. So this is what we're going to be discussing this week in classes. We're going to look at how to take a multiple of a number, or how to take a number that we know is a multiple and break it down into its factors, so we can find the prime factorization and understand that most important idea in numbers, the fundamental theorem of arithmetic. The most important thing that we need to know about numbers is that they're just made up of prime numbers. And if we can understand what a prime number is and that numbers are made up of prime numbers, that gives us so much information to work with for how to do computations and important things that come up in algebra. So once again, this is Numbers for Algebra. If any of this seemed useful or helpful, or if you would like to know more about how we approach numbers for algebra, we always like to start by asking the question, what is algebra? Algebra is the study of functions of real numbers. So before we try to understand what a function is, before we try to understand that concept as a prerequisite to algebra, we should have a pretty solid understanding of what is a real number. What are the properties of real numbers? What are the operations on real numbers? How do we multiply, divide, subtract, add, all those good things. And so we spend a lot of time in this course trying to understand what we mean by a real number, right? The real numbers are made up of those rational numbers, the fractions. There is also the irrational numbers, those decimals that can't be written as fractions. We have the integers in there, the positive, the negatives. We have the whole numbers, the natural numbers, and of course the prime numbers. And so if you are an adult planning to take college algebra and you'd like to learn more about how numbers work in a way that is useful and directly applicable to algebra, join us every Tuesday at what time is it? 4 p.m. Eastern for Numbers for Algebra. And once again, I am Darren. This is tutormymath.com. You can be successful in math. Don't let math be the thing that holds you back from passing your professional certification, getting your college degree, going back to school, whatever it is that your goal is. Don't let math be the thing that holds you back. You can be successful in math. Thank you for watching, and please feel free to reach out if you have any questions.